Bismillahirrahmanirrahim. Welcome to my channel Learn Math with Sayyid Ali. One of my 11th grader has sent me this question, and it's continuation of the same topic, angles for grade 11, and the continuation is into the primary trigonometric ratio. So here is the primary trigonometric ratio, sine, cosine and tangent. And we learned in the previous classes that to remember what sine equals to, cos is equals to, and tangent equals to, we say that SOH, TOA. What does it mean? S for sine, and it says SOH, so that means opposite over hypotenuse, right? And then C for cos, and CA means adjacent over hypotenuse. Tangent, T for tangent, and TOA, O, opposite over adjacent. So this is how we remember our three primary trigonometric ratio, that what they are equals to in a right angle triangle. Now we have two pictures here, and we learned in the past lecture that CAST is the rule for the sign of the trigonometric ratio. We say in the first coordinate, all positive. All trigonometric ratios are positive in the first quadrant, and C indicate cosine. So cos is positive in fourth quadrant. So in the second coordinate, sine is positive. Sine positive in second quadrant, right? We have done in the separate lectures for these, but this is like a sum up of all those things, because question is such. I will write down what the question is being asked. So in the third quadrant, tangent is positive. So tangent is positive in third quadrant. All others, when I say tangent is positive, that means all others are negative. Sine is positive in second quadrant, all others are negative. All positive, cosine is positive in the fourth quadrant, all others are negative. All other are negative, right? So whenever we say that cos is positive or tangent is positive or sine is positive, that means all others are negative. So this was our basic development, and now we have R, a vector or a resultant, as a terminal arm. We learned that if it is this theta or beta or whatever angle it is, so this moves initial arm to the terminal arm. What they form? Initial arm moves to the terminal arm. What they form? An angle. That is the development of the angle, right? And in first quadrant, we learned that theta is equals to beta, right? So we have no worries here. My R is there, right? So I can write theta or beta in the first quadrant. So theta and beta are equal. So I can say here maybe beta, right? So now if I want to get the components of this resultant R, I can drop a perpendicular here. Now I have two components of this R, right? And my triangle is like this. I can review this triangle here largely, right? A big one. So this is my resultant, this is my beta, and this is my y component of this R. And this is my x component, and I need to know what are my x and y component, right? Component, x component and y component. These two components make my resultant R, right? And with the help of the trigonometric ratio, we can find out that what these components are, right? If I say, okay, for this triangle, sine beta. So what is sine beta? Opposite over hypotenuse. So opposite over hypotenuse I can put up here. So I have y, opposite is y, divided by hypotenuse is r, right? What is my y equals to? y equals to r sine beta, right? So that means y component is always the sine component. If I take my cos beta, what is cos beta? Equals to adjacent over hypotenuse. So what is my adjacent in this triangle? X component. So x divided by r, right? If I want to find out x, it will be equals to r cos beta. So we are learning here that x component is always a cos component and vertical component or y component is always a sine component, and these are very important trigonometric relationship. Now if I take tangent beta is O over A, opposite over adjacent. What is my opposite? Y, right? What is my adjacent? X. So if I want to calculate tangent beta, that can be equals to y over x. Or a very interesting relationship we developed last time, that tangent beta is equals to sine beta over cos beta, right? Sine over cos is tangent. So if we put sine beta value and cos beta values, sine beta is y over r and cos beta is x over r. So what happened? R and r cancels. What we have is y over x. And what is our y over x? Y over x is tangent theta. So that means we have a very important relationship here, which I would like you guys to note it down and memorize. It will work for a longer time here in this trigonometry, like 11 and 12 grade trigonometry, and even after that in engineering or in physics. Tangent beta is equals to sine over cos, whatever theta, beta, gamma. So we see that tangent beta is a ratio of sine and cos. Tangent is ratio of sine and cos. Now, if you have this one triangle, and now my theta and beta are different because my theta is always anti-clockwise. You remember? Anti-clockwise. Initial arm to the terminal arm. So this is my theta, right? Or principal angle. And my related acute angle is this, which is beta, right? If I want to calculate beta, I can draw this triangle again at large. So I will say, if I drop a perpendicular from the arrow, I have this triangle, right? So if I have this triangle, so now I have my theta and now I have my beta. Theta is this, right? Principal angle. Principal angle is always anti-clockwise. We learned that, right? So this is anti-clockwise, right? And this is beta. And from this point, if I drop a perpendicular like previous, I have a right angle triangle for beta. So this is my beta. This is my r. This is my y component. This is my x component, right? And this is my right angle triangle. So now what I'm looking at is sine beta, cos beta, and tangent beta. Again, the same thing, right? So sine beta is O over H, opposite over hypotenuse. So y, opposite is y over hypotenuse, r. Cos beta, adjacent over hypotenuse, so x over r. Tangent beta, O over A, opposite over adjacent, y over x. Same thing, right? So this is just a relation. We are just revising everything. The cast, the values, the primary angle, or the related acute angle, right? So everything is on this page now, because we are going to solve a question based on all this what we have learned so far. Here again you can see that y component is the sine component. Y is equals to r sine beta, right? Y component is always sine component. Here x component is cos component, r cos beta, right? And here we learned that tangent is always a relationship of sine beta over tangent cos beta. This is what we learned so far. So to make some space and to mention the question, which is not that difficult after this all background, I will write down the question now here and solve it for you, right? hope you will understand the question when I will write down the question for you, and then step by step we will be solving it. Question is point 4 minus 7 is on the terminal arm, right, of an angle theta in standard position, right? Now we have to find out the following. A, sketch the angle theta. B, determine the radius, R. C, state the 3 primary trigonometric ratio. State 3 primary trig ratio. You know, sine theta, cos theta, and tangent theta. D, what is RAA and PA? So this question consists of 4 parts, but they are all easy to solve because we learn everything regarding the point, the terminal arm, the theta, the beta, and all those things, right? So I will start with drawing this because we have to sketch the theta. So what is happening here? I have a point given 4 minus 7, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. 4 minus 7 is my this point, right? 4 minus 7 is my point, right? So my R is like this. This is my resultant, right? Because this is on terminal arm. So my terminal arm is here. So what my theta will be, or the primary angle, that will always anti-clockwise, right? So we start from the initial arm and go to the terminal arm, right? So we have to do this. So this is my I have to move anti-clockwise, principal angle, right? So principal angle, right? So this moves from initial arm was here, and initial arm moves across anti-clockwise direction to reach 4.4 dash minus 7. So this is my theta, which I draw here. This is my principal angle. And what is my related acute angle? That is always to the nearest x-axis and in related acute angle, right? So this is my beta. So I have to calculate related acute angle. I have to calculate my my RAA, related acute angle, and principal angle. I have to show where the resultant is, right? So I have my resultant here. Now he's saying, if you want to put the cast as well, so you should know that what will be the value of different trigonometric ratio. So in this coordinate, in 4th quadrant, you know that cosine is positive. So we will see that cosine will be positive, all others will be negative when we calculate these ratios, right? Now, B part is sketch the angle, determine R. So R, right? So this is my minus 7, this is my 4, and this is my right angle triangle, and this is my R, right? So we know this is my right angle triangle, so R can be equals to, R square is equals to 4 square plus minus 7 square, which is equals to R square is equals to 16 plus 49. R square is equals to how much it will be? 65. So R is equals to 8.06, and I can reduce it to, like, I can say 8.1, right? So this is my B part. This is my A part. This is my B part. What is the R? Determine R. So we determine R here, right? Now, what is C part? State the three primary trigonometric ratio. So sine beta is equals to, what is sine? Opposite over hypotenuse. What is opposite here? Minus 7 over 8.1. So if I calculate this, this will be equals to sine inverse of some value which is minus, how much minus? 0.86419, right? If I take sine inverse of this, I have my beta. So beta is equals to minus 60. And it has to be minus because it is in the fourth quadrant. Cosine is only positive. Other trigonometric ratio will be negative. Now I check my cos. Cos beta is equals to A over H, adjacent over H. My adjacent is minus 7. My adjacent is how much? 4. My adjacent is 4 divided by 8.1. So what will be equals to sine inverse, cos inverse, sorry. 4 over 8.1. 4 over 8.1 is like 0.4938. Right? If I take this cos inverse, so I can get my beta. And beta is equals to 60 degree. And cos should be 60. So I have got my value positive, which is 60 degree. And then I calculate my theta, tangent theta. Right? Tangent beta is equals to, beta is equals to, what is tangent? O over A, opposite over adjacent. Right? Minus 7 over 4 in this triangle, which we calculate tangent inverse of what? Minus 1.75, and that will be giving me minus 60. So we have done our three primary trigonometric ratio. He is not asking actually the beta, he is just asking for the trigonometric ratio. So ratio is, you can stop it here because ratio is here. If you take for your like curiosity that what beta is equals to, it gives you all the time beta is equals to 60 degree, right? So we have beta is equals to 60 degree. Now we have another part, C part and then D part, the last part of the question. What is RAA? Related acute angle. So we know that related acute angle is RAA is 60 degree. We calculated several times. It is 60 degree. If RAA is 60 degree, what is my PA? So we know that PA is, what is PA? 360 minus 60. So my PA is 300. My theta is 300 degree. This is theta, which is equals to 300. Now we calculated 300 degree, right? So these are my answers for related acute angle and principal angle. So we did all our knowledge into this, utilize our knowledge into this question where a point was given on the terminal arm of an angle theta in standard position, and we sketch the angle, we find out all the relevant parts. I hope you understand and you like the video. If you like it, subscribe to my channel, press the bell icon button. Thank you for watching.